All right, so let's review factoring. So the first thing I want to do is look for the GCF. Can somebody tell me what the GCF is on this one? What does greatest common factor? What does everybody have at least one of?
1.
X. Right. Everybody has an X. When I factor out an X, what's left over?
X minus 4.
X minus 4 equals 0. All right, I need to look for square roots. Do I have any square roots?
Yes. No. No, you don't.
No. Do I need to factor this anymore? Number 3 is factor it. It's basically already factored, correct? Does anybody know what this means, what we're trying to find when we do factor? From Algebra 1, do you guys remember? No? Trying to find where the graph crosses the x-axis. So where the graph crosses the x-axis, we can found it's also called X Intercepts, or you may recall zeros. Well, in order to find the zeros, we set everything up to 0. Okay, so X Intercepts and Zeros. So if I set both of these things, if I have A times B and they equal 0, it means that one of them equals 0, correct? So that means that this is what this looks like. This is really multiplying X times X minus 4. So I have X either has to be 0 or X minus 4 has to be 0. Well, this one's already solved, and X equals 4. So my zeros are at 0, and 1, 2, 3, 4. So this would be a graph that looks like this. Remember what we said about the shifting, and I said it's the behavior of the graph is going to follow into a parabola? See how this is X minus 4 and it shifts over 4? It's the same concept, right? Okay, go ahead and copy that down. 1. All right, so let's try this one. This one looks a little bit different, right? Especially since it doesn't have a 0. So what can I do so it does have a 0? Add 36 to both sides. So we'll begin with x squared plus 12x plus 36 equals 0. All right, do I have a GCF?
No.
No GCF, not something that each one has, correct? Do I have any square roots?
Yes.
I do. This will come into play later. All right, so if I factored this out, I'm going to do it 2 different ways for you. If I were to multiply x times x, I'd get x squared, correct? If I were to take 6 times 6 is 36. You see how this square is in the first place and this square is in the last place? Now I just have to figure out these two signs. So this is what I would call my rainbow method. What is 6x plus 6x? 12x. Does that match there? So if I would have looked at this one, x times x is x squared, and 6 times 6 is 36. And if I do the inner and the outer, you guys know this as FOIL, correct? All right, so I'm just kind of doing FOIL in reverse. I look at my first, that's what these two have to be made up of. I look at my last, that's what these two have to be made up of. And my inner and my outer have to add up to 12x. Or I could have just gone right here to this step and said that x squared plus 12x plus 36, I guess we could have done it here, is actually x plus 6 squared, if you recognize that, because that's one of your special products from Algebra 1, which I don't expect you to absolutely remember, but we'll get into that later. Okay, does anybody remember the Xbox method on how to do this? So for the Xbox method, we call, I'm going to change it to red, we call, here's my A, here's my B, we'll change that and put it here. Here's my A, here's my B, and here's my C. How many of you raise your hand if you've never seen the Xbox method? Everybody seen it? Only one hasn't seen it? Okay. Okay, so they call it the Xbox method, but I always say it should be the box X method. All right, because you want to put in A and C first. This is your B's, but your B's get split up. We find the B by using the X. So if I put in A, what is A? X squared. And what is C? 36. And to find these two numbers, even though we already know what they are, what are they? 6x and 6x. We already know what they are, but if I needed to find them, I could multiply A times C, my A times my C, and this is my basement, and then it's the same type of graphic organizer that we were using in the beginning. Right? What is A times C? What is x squared times 36? 36x squared. And what's B? 12x. What two numbers, when I multiply, give me 36x squared, and when I add, I get 12x? 6x and 6x. And that's how we know what went in here. Okay, so why do we use this Xbox method? When it doesn't go in perfectly, when we're trying to second guess how to do this method, right, straight factoring. Okay, so we use it to factor. So this is basically like a multiplication table. For instance, if you have this multiplication table, and this is 6, what two numbers do you have to multiply to get 6? 2 and 3, right? And this would be 8, right? Would be 4. What would be the next number? 10. Like it's a graphic organizer that you're using for multiplying. Do you notice it also looks a lot like, I was sharing this with my daughter, division? So, you see what I'm saying? Because division and multiplication are just inverses of each other. Okay, so let's factor. What times what makes x squared? X and x. X times what makes 6x? What times x makes 6x? And 6 times 6 makes 36. So these are my factors, just like we have here. X plus 6 times x plus 6. Let me connect this to a graph. What does this mean graphically? Can you explain it to me? How about Dominic? Dominic, can you explain it to me graphically what this means? When I factor,
There's only one root.
it means there's only one root. And where is that?
I'm trying to remember if it would be the highest point on it.
Well, if it's a positive graph, it's smiling, right? So it would be positive, and it would be the lowest point. Where would the lowest point be, though? Where would it cross the x-axis? Perfect. 1, 2, 3, 4, 5, 6. So it would be a parabola, smiling upward. I know that it has a regular slope because the slope in front of x squared is 1. All right, write as much of that as you need. 2, 1. Okay, let's look at another one. This time I'm going to start with the X box. Does anybody know why I'm going to start with the X box on this one? It's the 2, that coefficient, right? All right, so let me draw a line down the middle. And I'm going to go ahead and go through both methods. Can I get rid of this now? Is that okay? All right, so first I'm going to identify my ABC. So here's my A, here's my B, and here's my C. I'm going to do an X box or a box X. Okay, so like I said before, we want to put in our A and our C first. So what's my A? 2x squared. And what's my C? -3. The reason I do this is this. When I find this, I have to multiply A times C. What is A times C? -6x squared, right? 2x squared times -3 is -6x squared. Students that do this part first, the X part first, tend to put -6x squared in this box. It's a common error. So that's why I do it in reverse. I fill in the box first, then I use the X to find C and B. Okay, I want my basement. My basement's -x. So what times what? When I add, I get -x, but when I multiply, I get -6x squared. -3x and -2x? That doesn't work. +2x, thank you. Because when I add them, I'll get a -x. It doesn't matter. It doesn't matter which box I put it in, but I should line it up with common factors, right? That -3x would probably be a lot easier if I put it right next to that 3, and the 2x with the 2. So I'm going to go ahead and factor. Let's do this in blue. What's the greatest common factor of 2x squared and 2x? 2x. 2x times what makes 2x squared? 2x times what makes 2x? 1. 2x times 1. What's the greatest common factor here? -3. -3 times x is -3x. -3 times 1 is -3. So I know my factors are x plus 1 times, 2x minus 3. What are we finding again? Finding what? Intercepts. Exactly, I'm finding intercepts. So, how could I find those intercepts based on this? Set them equal to 0. X plus 1 equals 0, and 2x minus 3 equals 0. X equals -1. Add 3 to both sides and divide. X equals what? 3 over 2. So -1, 3 over 2, can I have a fraction? Why not? You guys get scared of fractions, right? I don't blame you. They've been scary for a while. They won't be after this year's over. So -1, 3 halves is 1 1/2, right? So I'm going to go over 1 1/2. All right, I'm going to do it with the rainbows and checks method, is what I call it. All right, so if I have 2x squared minus x minus 3 equals 0, and I consider my first. Here's my first. This is where my first has to be. What times what makes my first? 2x times x. See that? What makes my last? 3 -1. I'm going to do it this way, just for demonstration purposes. Now I do my rainbows and checks. Here's my inner. Becomes -x. Here's my outer. becomes 6x. Does that add up to negative x? No. So I need to erase it and come up with a different strategy. This is why people don't like this method. So instead of being negative 1 and 3, couldn't I use the commutative property and switch those around and make it 3 and negative 1? Correct? So now I'm going to do my inner and my outer. My inner is, I forgot to put last. Here's my last. Okay, so my inner is 3x, and my outer is negative 2x. Did I do that right? It's still not right, is it? What's wrong with it? The 3 has to be negative, and the 1 has to be positive. It's kind of a guess and check method, right? So now I have negative 3x and positive 2x. Does that work? Do you see why I call it rainbows and checks? These are like upside down rainbows, and I'm checking to see if it works. I know some of you have different methods, and that's great, and if you're successful with those methods, please use them. I'm not going to use any more than these two, because I think these are the two most used. Okay? So my factors are 2x minus 3 and x plus 1, just like we had over here, 2x minus 3 and x plus 1. Question so far? All right, let's look at this one. I'll do this one really quickly. I'm going to use my rainbow method. First, what times what makes x squared? X and x. 33. What times what makes 33? Mindful of when you add it, you have to multiply it to make 33, but when you add it, it becomes 14x. 11 and 3. This is a plus sign. This is a plus sign. Does it work? I'm going to move all this. Does it work? Let me check. Here's my rainbows and checks. That makes 11x. That makes 3x. Add them together, 14x. I'm doing this because this is actually a lot easier than doing the x box, but I think students are intimidated when this coefficient is more than 1. So I figure that if we just do it with the easy ones, you could get used to it and then ease into it later, because I think when you get to math analysis, if you pull out an x box, they're going to laugh. Okay? Okay. All right, let's move on. Anybody need time to copy that down? Give you a quick second. Let's try another one. All right, so I'm going to use the whole rainbows and checks method. What two numbers, when I multiply, I get 6x squared? 3x and 2x. Good. All right. What two numbers, when I multiply, I get 4? 2 and 2. Let's see if it works. I've got a negative here. I've got a negative here. If you have a negative here, that means 2 times 2 has to be negative 4. Does that mean both of them are negative or one of them is negative? 1 is negative. Means 1 has to be negative, right? Okay. Does this work? 4x and negative 6x. Does that work? Did my rainbow and check work?
No.
No, it didn't. Does it matter if I switch the 2's? Or maybe if I make this one negative and this one positive, will that work?
No.
What did I say? This one negative and this one positive? So that would make this negative 4x and this positive. Would that work?
No.
No. So what should we do? Try 4 and 1. This is the way I learned. This is old school. 4 and 1. Is that going to work? That's going to be 8x. That's going to be 3x. I think it will. Let's try it. Negative 8x and positive 3x? That's not going to work? It does work, right? Am I right?
You are.
I am. Anybody interested in me doing it over here?
No.
How about just in case?
I'm never going to try something.
I'm going to try A and C. So A is 6x squared, and C is negative 4. 6A times C is negative 24x squared, and B is negative 5x. What two numbers make up 24? 8 and 3? Negative 8 and 3. So I'll put the negative 8x here and the 3x here. Okay, what's the greatest common factor here? 3x. 3x times what makes 6x squared? 2x. 3x times what? 1. This is negative 4. Negative 4 times 2x is negative 8x. Negative 4 times positive 1 is negative 4. Did we get the same thing as we did over here? This, there's no errors. You just go straight to it, right? This one is a little bit of guess and check. All right? Either way will work. Do you see that really didn't go that slowly? So finally I need to do what? What's the last step?
Zero.
Set it to 0, because what am I trying to find? X intercepts. So 3x minus 4 equals 0, and 2x plus 1 equals 0. You should be able to see this one. Which way is this going to shift if I was talking behavior of a graph? It's going to go left by how much? A half. If 2x is 1, how much is 1x? A half, right? All right. So if I set this equal to 0, I'd add 4 to both sides. I'm just trying to get you guys to think about that stuff. So x equals 4/3, and x equals negative 1/2. Let's do our closing thoughts. Oh, what's this one?
5.
36, x squared, subtract 25. What did I say on that second step? Look for squares. Isn't this 6x squared and this is 5 squared? This is the difference of two squares. Oops, I forgot my square. So what goes in my first? 6x and 6x. And what goes in my last? 5 and 5. And plus and minus. You guys remember that? Difference of two squares? If not, we need to really go over this after school because this will save you a lot of time.